Definition. A relation is a set of ordered pairs, x, y, that matches items in the domain, the x values, to items in the range, the y values. So here's a set of ordered pairs, so that's a relation. The domain, and this is of an xy coordinate point, domain are the x values, which are 1, 2, and 3, and the range is the y values, which are 3, 2, and -1, domain and range. What we're going to be primarily interested in is the idea of a function. A function is a relation that matches one item in the domain to one item in the range. We say a function is 1-to-1, 1x to 1y. So if I were to do what's called a function map, that's the domain, that's the range. 1, 2, 3, 3, 2, -1. 1 matches to 2. 1 goes to 2, 2 goes to 2, and 3 goes to -1. If I were to cover up the y values, this would be a function because it would be a single x going to a single y. Now, what would not be a function if I had something like this? 1, 2, 3, 4, 5, and you'd say 1 goes to 3, 1 also goes to 5, 2 goes to 4. Now if I cover up, 1 goes to more than one place. So that says that this is not a function. So it's 1x to 1y. Now you could have a y value that is repeated. So for example, I could say 1, 2, 3, 4, 5. 1 goes to 3. 2 also goes to 3. Notice that's still a function. That's still a function. 1x to 1y, because they go to the same y, makes no difference. Oftentimes, the further along you go in mathematics, you have names, and this says the x value is often called, because it's the domain, it's the independent variable. And that's because most of the time, if I'm dealing with the independent variable, I choose x, and a result, I get y. Y would be called the dependent variable. It's the independent variable, and this is the result of choosing x. Independent and dependent variable. Domain. Functions have a domain, and that's going to be extremely important to us as we kind of move forward. The domain would be all real numbers, because that's all we're dealing with in this class, is all real numbers, and except for things that can happen. First of all, it can't have a denominator, or the denominator can't equal 0. So in this case, this is a fraction. It's got x's in the denominator. The denominator can't be 0. That means that x squared minus 1 can't be 0. This factors in the difference of squares. Or in this case, x can't be plus or minus 1. So the domain would be all real numbers except that. And I use this notation for all real numbers. So I would normally write this as all real numbers, and that would be what the domain would be. And also that the radicand, that's the number that's under the radical, must be greater than or equal to 0 for even indexed radicals. This is a square root. That means the index is 2. So it's even. So this would mean that 1 minus 3x has to be positive, greater than or equal to 0. Or negative 3x has to be greater than or equal to negative 1. Or x has to be less than or equal to negative 1 over negative 3. Remember, I'm dividing by a negative number. So when I divide both sides by that negative number, it reverses the direction of the inequality. Or x is less than or equal to 1/3. I can't put any numbers bigger than 1/3 in, otherwise it would be imaginary. How do we evaluate a function? Put in x, get out y, and in this particular instance, we look at f of negative 1. Well, that would be f of negative 1. You pull out the x, and in its place, you put whatever is here, which happens to be negative 1. So this is negative 5 subtract 2, or negative 7. So as a function, negative 1 goes to negative 7. And g of 10, now in this case, negative 10, again, g of negative 10, I would take negative 10 minus 3 times negative 10 plus 2. Now notice I am squaring x, so that's why I have the x in parentheses. So this would be 100. Negative 3 times negative 10 is positive 30 plus 2. And this looks like it is going to be 132.